Okay, so we're going to continue today, and today we're going to move into the next stage of these conversions. And today we're going to do the following. We're going to convert moles to grams and grams to moles. You don't have to write this down. Moles to grams, and then grams to grams. So mass to mass, basically. And then we're also going to do grams to volume. So when I talk about this, I am talking about using the mole tool here. So we're going to be going from mass of one substance to mass of another substance in the equation. So we're going to be going from here, then we have to go to moles, and then switch to the other substance. Because here's the thing, and this is super important. You only can switch from one substance in an equation to the other when you're in moles. Only. So in other words, let's take a look at our first problem, and I'll clarify this. In the first problem, it says, how many grams of potassium chloride are produced when you have 6.32 moles of potassium chlorate? And they're going to decompose. So if I write what I have, which is 6.32 grams of potassium chlorate right here, and what I want to know is how many moles. Wow, totally messed this up. I'm correct. Sorry. Okay, corrected. I start with 6.32 moles of potassium chlorate. And what I want to know is how many grams of the potassium chloride I'm going to end up with. Okay, now what I meant by you can only switch when you're in moles is I have no way to switch from moles of potassium chlorate to grams of potassium chloride without going through moles. So if I look at the mole tool, which, by the way, you should all have on your periodic table by now. If I look at this, I have no way of going from moles of one substance to grams of another substance. I have to first go from moles of one substance to moles of another substance, and then I can go to grams. But where you switch from substance A to substance B is in moles. And it can only happen in moles. Never, ever, ever can it happen in any other way. And usually I say in college, but today it's here. Nope. Can never happen anywhere else. Never. Ever, ever, ever. Even chemists in chemistry factories, they can only switch in moles from one compound to another, okay? So when you're switching from grams of one thing to grams of another, you have to first go to moles. And then you use that molar ratio, just like you did yesterday, just like you did last night, to switch compounds. All right, so let's see how that works, okay? So first, I'm going to start with what I'm given, which is 6.32 moles. So that's nice because I'm already there in moles of KClO3, potassium chlorate. And now what I need to do is I need to switch from potassium chlorate over to potassium chloride. So I'm going to do that using the molar ratio, just like I did last night, because I'm in moles of potassium chlorate. So that's 2 to 2. So 2 moles of KClO3 to 2 moles of KCl. Now, it's kind of important that you start to label your units with the compound that you're using. And the reason is because we're starting to have more than one compound in an equation. So it's important that you have more than one compound, all right? All right, now I'm in moles of potassium chloride. And what I want to do now is I want to go to grams of potassium chloride. And so now I'm just going to use my molar mass to go from moles to grams. All right, so all I'm going to do is use my molar mass to go from moles to grams. So what goes down? 1 mole of KCl. And then what goes up is that molar mass. And so I've listed the molar masses over there to the right of the problem. So you can see that KCl is 74.55. Now I can cancel out my moles, and I'm left with grams of KCl. Now I run this through a calculator, right? And I'm going to get 4.71 times 10 to the 2 grams of KCl. Notice I have 3 digits here and 3 digits here. I could have 4 for the molar mass, but 3 is less than 4. Right here is my molar ratio from my equation, 2 to 2. That's where I switched from potassium chlorate to potassium chloride. I went from moles to moles, and then, only then, was I able to switch and go out to grams. Questions? Okay, let's take a look at the next one, all right? In the next one, I'm not given moles of the starting number. I'm given grams of it. Remember, I can't switch from one compound to the other unless I'm in moles. So no matter what I start with, I have to get to moles to switch to the other compound. So in this one, I'm going to use a different color here. I'm given 25 grams of potassium chlorate. So I'm going to go up here and put my 25 grams. And what I'm looking for is my grams of O2. Okay, how many grams of O2? So I'm going to start with grams of potassium chlorate here. I'm going to have to go to moles of potassium chlorate. Then I can switch to moles of O2 and then go out to grams of O2. Okay? So let's try that. So I'm going to start with my 25 grams of potassium chlorate. I have my molar mass of potassium chlorate, which I put up on the board over there. So that's 122.55 grams of KClO3. Notice that I'm carefully labeling everything that I'm using, every unit that I'm using. 1 mole of KClO3. And now I can use my molar ratio to switch from KClO3 to O2. So 2 moles of potassium chlorate to 3 moles of O2. And now I can keep going. 1 mole of O2 And I put up the molar mass over there to 32.00 grams of O2. Here is where my molar ratio is, right there. That's where I switch from one to the other. Rylan. Here? Yes, thank you. So when I run this on my calculator, I get 9.8 grams of O2. Okay, but we also can do, using the mole tool, we also can go like from mass to volume, and we can go from volume to molecules. We can do all of these things. But every time we switch compounds, we switch in moles. That's the key here, all right? Okay, so let's see how this works. So again, I'm going to use the Haber process. Okay, and so the question is, what volume of H2 is needed to react 5 liters of nitrogen? So remember, the conversion here from the mole tool is 22.4 liters is equal to 1 mole. So we have 5 liters of nitrogen, and we're looking for liters of hydrogen. Right? So I'm going to start with 5 liters of nitrogen. And I have to get to moles. So 22.4 liters of N2 to 1 mole of N2. Right? And now I'm going to switch from nitrogen to hydrogen. So that's a 1 to 3 molar ratio. 1 mole of N2 to 3 moles of H2 . And now I'm going to go to liters of hydrogen. This is the last problem, so stay with me, okay? So I'm going to go 1 mole of H2, and we're almost done. Hang in there to 22.4 liters of hydrogen, and then watch me cancel, and then we're done. We're not going to solve. I'm just going to cancel. So I'm going to cancel my moles, cancel my moles, cancel my liters, but look, I can also cancel 22.4. See that? Right. So since I'm going from volume to volume, I just end up multiplying across the top. Do you see that? Now, I think tonight you're just working in mass to mass. So I think you're just doing grams to grams tonight, all right? So tomorrow we'll do some practice problems on the other things, but we're also moving forward. So make sure you get that homework done. Make sure, okay?